Okay, so the next section here, right, is about sketching graph related to the general gas equation PV equals nRT. So students typically find this part challenging, but actually this is more math than chemistry lah. So if you know your math well, right, sketching graph shouldn't be so tough for you. Okay, so let me just illustrate to you what do I mean here. So the basic shape of most of the graph that you're going to sketch, right, will have generally this kind lah. So it's either y proportional to x, right? So this one is typically like the Boyle's law that we have mentioned earlier on. So because this one looks like y is equals to a kx graph. So k is a constant. Okay, so this looks like a y equals to mx graph. So if your y is proportional to the variable x, right, you will expect it to be a straight line that passes through the origin. So a good example would be, remember your Avogadro's law. So this is where v is proportional to n. So when v is proportional to n, you see that your v is your y-axis. So this is like v equals to kn, right? So this is your y-axis, this is your x-axis. Okay, and then this is like your gradient. So you will see that it is a straight line that passes through your origin. Another example that we have looked at would be your Charles' law, where v is proportional to t. So remember, so when you have v here and then your t is in Kelvin, so v is equals to like kt, so it should be a straight line that passes through the origin. Can? So I would like you all to actually take this down as well. So we have another graph, so which is where y is proportional to x also, but this one here, right, looks more like a y equals to kx plus c graph, or y equals to mx plus c graph. Okay, so this is the situation where we have discussed the earlier part here, where if for example you have a y-axis being your volume, and then your T is not in Kelvin but in degrees Celsius. So remember that it will be a straight line that passes through, that doesn't pass through the origin, but it will cut through your y axis, and there will be a c-intercept here, and then it will go all the way to minus 273. Okay, so this will be how it looks like. Can? So then of course we also have another relationship where y is proportional to 1 over x, or y is inversely proportional to x. So this is typically like y equals to kx graph. Okay, so that's why you see that y decreases as k increases. Can? So this is the example that we have seen in our Boyle's law. Alright, so remember Boyle's law says that pressure is inversely proportional to volume. So yeah, so this will be the Boyle's law that we have seen. Okay? Then of course, we will also have a situation where y is equals to k. Okay, so this means that it is constant, it doesn't change. So regardless of how your variable x change, y will be independent on x, because y will always be equals to a constant. So this is similar to what we have seen in your Boyle's law. So remember, P is inversely proportional to V, right? So that means that P is equals to K over V. So P times V is equals to K, which is a constant. Agree? So therefore, if I were to plot PV versus V, it will be a horizontal line. It should be a constant. If I were to plot PV versus P, it should also be a constant. Alright, so this constant should be the value of K lah, depending on what the value is. Can? So that's what it means here. Okay, so with that, let's try to do exercise 3. Okay, so exercise 3, you are told to sketch a graph of B against T for a fixed mass of gas at constant P. So this would tell you that N is equals to constant and P is equals to constant, right? So if you were to look at the equation, PV equals to nRT. Okay, let me use blue. PV equals to nRT. So N is constant, P is constant, and of course my R is constant. Okay, so what I can do is I can manipulate this equation such that I bring the constant to one side. So I V equals to NR over PT. So these are all constant. So these are all constant. So I can let it be K. So do you see that this particular equation, right, can be simplified to V equals to KT. So this is like my y-axis, this is my x-axis, this is like y equals to mx. Okay, so therefore if I were to plot a graph of of B versus T, I should expect this to be a straight line that passed through the origin. Okay, so it looks like a y equals to mx graph. Make sense? So now what happens if I were to change my x-axis to temperature in degrees Celsius? So again, if you look at the math, right? So this is the math. So it's V equals to NR PT. So if I were to convert my temperature from degrees Celsius to Kelvin, right, what should I do? I should always add 273, right? So this looks like NRP. Then I have my T plus 273. Agree? So I can just expand this to NRP T plus 273 NRP. Okay, so does this look like a Y? This is like your M, this is like your X, and this whole thing is like your C. So this look like the Y equals to mx plus C graph. So therefore it should be a straight line, but there will be a y-intercept. Okay, so that will be a y-intercept, and usually we'll extrapolate all the way till minus 273. Why minus 273? Because this will be your 0 Kelvin, right? So this is the absolute 0. So usually we dot 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 because there's no way that we can reach 0 Kelvin in reality lah. So but this should be a straight line. So this is how we will draw it. Okay? Okay, so now let's look at exercise 4. Exercise 4, you're supposed to sketch a graph of P against 1 over V for a fixed mass of gas at 2 constant temperature. So this tells you that N and T are constant. Okay, so I have PV equals to nRT. So now N, T, and R are all constant, right? So that's good. That means that basically I'm now supposed to plot P versus 1 over V. So I can say that this is equals to nRT 1 over V, right? So this is like my y-axis, this is like my x-axis, and this is my M. So what does it mean? It means that my gradient is simply the value of nRT. So if it looks like a y equals to mx graph, right, I should expect it to be a straight line that passes through the origin. Okay, but I don't just sketch for one, I'm supposed to sketch graphs, meaning more than one, and I have T1 and T2, and I'm told that T1 is greater than T2. So if this represents T1, right, so remember the gradient here, the gradient equals to nRT1. So now if I have to draw for a second graph, so for T2, right, basically it means that the gradient nRT2 should be smaller than the gradient of nRT1. Why? Because T2 is smaller than T1. Agree? So therefore, I will expect for T2, it should be another straight line that passes through the origin, but of a smaller gradient. Okay, so in other words, you can tell that at higher T, it means steeper gradient. Okay, so that will be how you answer this question for exercise 4.